So this is the last lecture for lesson 2 of chapter 4, and some of this is going to be a little bit of review. I know we've talked about pretty much all of these concepts before, but we're kind of just going to bring them together and elaborate on them. And we're going to start by talking about ocean basins. An ocean basin is a large area of Earth's crust that is below sea level and it is covered by salt water. It's a pretty basic definition, and we've looked at how they are formed. Just give you an idea of kind of what they look like. This is just an example of an ocean basin. You have your continental crust, oceanic crust, and the basin is kind of like a bowl shape. So this is probably like half of it here. You have your different features, which we're not really concerned with most of these right now. We're not going to do an in-depth study, but just to give you an idea, you have your deep ocean basin, your continental margin, continental shelf, your coast, the continental slope and rise, and oceanic crust, continental crust, abyssal plain, and then ridge, and we've looked at volcanic islands, and we'll talk about the ridge later, but I just want to give you an idea of what the oceanic basin looks like. And here's where we've kind of talked about it before. When we were talking about tectonic plate movement, we talked about how an ocean basin is formed, and it starts out as a rift valley. And one example of this would be the Rift Valley in Africa, but this is kind of an embryonic basin. So it's not really a basin yet, but this is where it starts. It's just as a rift in a continent, and as the magma is pushed up, it's not creating continental crust. It's creating oceanic crust. So as it creates that, it's obviously going to be more dense, so more tightly packed and thinner than the continental crust around it. And here's where we have the Rift Valley here, which would fill with water. And so an example of this young ocean basin would be the Red Sea or the Gulf of California. And so here we have the new oceanic crust that has pushed apart the continental crust, and now it is below sea level, so we have it filling with water. And then it continues to spread out, as we saw. So this is a divergent plate boundary. An example of a mature oceanic basin would be the Arctic Ocean, the southern Indian Ocean, the North and South Atlantic. These are examples of mature. So your full-on oceanic basins. So imagine here, this is the Atlantic, so you either have Africa or Europe here, and North or South America here, and its new oceanic crust is continuing to spread. And then you have a declining oceanic basin. Examples would be the Pacific, North and South Pacific. So what's happening is this is actually getting smaller. So even though more crust is being formed, it's actually going down into trenches. So we have subduction here. And then you have a terminal where only one side is being subducted. This is the Mediterranean Sea, and the Mediterranean oceanic basin is actually getting smaller because the terminal meaning it's ending. So this is an example of that. Now, lava, as we've seen, doesn't just erupt from volcanoes on land. We also have lava coming in between in the ocean, and so here's an example of an oceanic volcano or oceanic lava flow here. But you remember when we talked about Pangea and we talked about the continents separating, we talked about South America and Africa separating and North America and Europe separating about 200 million years ago. So what happens to the area in between? How do we get from this all the way to this? That's a lot of steps in between, but this is about 200 years from this first example, from this first happening in between Europe and North America, to what we have here today. So as we mentioned, lava will erupt at convergent plate boundaries and divergent plate boundaries. So the lava, it'll harden and it'll form, all kinds of different things, and it's added to the edges of these plate boundaries, and so it's literally making new oceanic crust, as we see here. Um, so as the plates move apart, more lava fills and creates more crust, kind of forcing it apart. And so the seafloor between uh, North America and Europe is actually growing. It's new ocean crust, and it was formed after these continents spread apart. So that's the newest parts of the crust are happening at these areas in the ocean. So we talked about how the ocean crust is made at divergent plate boundaries, and it's not flat. It's not coming out as, well, here's a brand new level floor. No, it's creating a ridge, and so we have mid-ocean ridges. So a mid-ocean ridge is a long, narrow mountain range on the ocean floor, and it's formed by magma at divergent plate boundaries. Um, the mid-ocean ridge in the Atlantic begins near the North Pole. So this is an example of this is the mid-Atlantic ridge. So, but it begins near the North Pole and it ends near the South Pole. So all the way down we have this. So North America, South America, Africa, Europe, all the way here. This ridge stretches, and it they usually the mountains that are formed there usually have kind of a gentle slope. They're not real jagged. They're usually only about 2 kilometers high. Now, remember when we talked about volcanoes, more explosive volcanic eruptions happen at convergent plate boundaries, so where the plates are coming together, but more lava erupts from divergent plate boundaries. So this is where the new crust is being formed. So there's obviously more magma coming out. Yes, we will see volcanoes. That's where the pressure is building up and it's exploding out. But more magma is actually coming through these divergent boundaries. In fact, 3/4 of all lava erupts at mid-ocean ridges. So as lava, it flows into the water and it cools very quickly, as we saw with our experiment last week. But it forms all kinds of unique shapes as it cools very quickly. Like here's an example of one of these are called lava pillows. So the lava flows into the water and forms these kind of strange shapes here. Now let's talk about mountains. We've covered this a little bit last week. We talked about mountains coming from when Earth's crust folds and it crumples, and tectonic plates coming together. And so remember, we have volcanoes forming at convergent boundaries where one plate subducts onto another. So we have this oceanic crust subducting underneath the continental crust. So we have that here. So volcanic mountains are formed that way. And you get these chains that happen along the coast. We see here along South America, and then North America we have that ring of fire here. So there's subduction happening of oceanic plates under continental plates. So we get those volcanic mountain ridges formed. You have the Andes and the Cascade Mountains up here were formed that way. And we also mentioned a little bit about how two continental plates converging and creating mountains. And the example that we looked at last week was the Himalayas. This is the largest, highest mountain chain, mountain range in the world, and they're actually still growing. And so what happened is we have the Indian subcontinent, and it converged with the Eurasian plate, and that's how we created the Himalayas. Well, that's how the Himalayan mountain range was created. And so you can see here the continental crust and continental crust coming together and forming this large mountain range. And we looked at this is how that happens. Another example of this, and I mentioned it briefly, was the Appalachians. And something interesting happened. These actually formed as Pangea was formed. So when the continents were together, we had these continental plates coming up and creating the Appalachians, but it actually formed a much longer mountain range that stretched from the Appalachians and included some of the mountain ranges in northwestern Africa and into Europe and through the Highlands in Scotland, and then the Caledonian Mountains in Scandinavia. And so this was all one gigantic mountain range, and then over millions of years, tectonic plates moved, and so we have these mountain ranges actually being separated. So there's a lot of similarities because between the Appalachians and the Caledonide belt here, which includes Scotland and Scandinavia here and some of Greenland, and then even the Mauritanian belt in Africa and the Variscan belt in Europe, because these were all at one point one mountain range. We can see kind of how it looks here. But these moved over millions of years, and when you look and compare fossils, when you compare ages of the mountains and similarities in their structure, we can actually see how these things were together at one point, and it just provides more evidence to the continental drift theory, to plate tectonic theory.